Already done a few panel sessions today, but with people that I already know for years. And now I'm in a panel with people that I know since today or yesterday. And I'm going to learn myself new things again because we're going to talk about low power design. And I know that we have some people here who are experts in energy harvesting. I've heard about it a couple of years ago, and then I thought it disappeared. But it's apparently happening. It's hot and happening. So we're going to learn some new stuff. But before doing that, quick intro. My name is Afzal, doing panels and podcasts lately, officially working for Deutsche Telekom, but in between jobs unofficially. So that's me, and I'm going to hand over to Niklas.
Hi, I'm Niklas Forsgren, Field Application Engineer Director at Epishine. And for you who already heard me, we are producing organic solar cell in a roll-to-roll fashion, enabling, hopefully, IoT at scale.
Hello, so my name is Klas Engstroem. I'm a sales director at Nichicon, and we are a manufacturer of storage elements, a special battery type out of technology called LTO, lithium titanate oxide, which is very suitable for energy harvesting.
Hello everyone, I'm Liliane Paradise and I'm the COO at Miromico. We are a hardware design house and we are basically the happy customers of these guys. But you'll hear more about that.
Hi, I'm Pierre GELPI. I'm in charge of sales for Europe at EPs. And at EPs, we are selling power management chips for energy harvesting. So basically the chip that optimizes the energy from the source to the storage element and the application for energy harvesting.
Great, thanks for the intro. So I promise we will talk about IoT energy harvesting. But before doing that, I want to take a few steps back because, as I said, I think I'm not the only one. But for me, even though we've been talking about this for years, the fact that it's really mature now, hot and happening, and already part of a lot of IoT solutions today, it came as a surprise to me, a positive surprise. So I want to take a few steps back, and I want to ask you guys first, who of you have been involved in the past in the deployment of IoT devices based on low power wide area technology? So LoRaWAN, narrowband IoT. Pierre? Yeah, of course. And you as well, right?
Yes.
Yeah, and the two of you? Okay, Klas? Yes?
Have been involved.
Okay, so a question to the three of you then. We started with LoRaWAN 10 years ago, yeah, and narrowband IoT 7, 8 years ago, LTM as well. So I'm wondering, do you already have devices that are running on, without energy harvesting, running on one battery for more than 5 years? Starting with Pierre.
Well, I was with Semtech before, so I started also LoRaWAN a long time ago. And it's a little bit what I was saying before, the promise of all these water meter and asset tracking projects and rollouts that we had with LoRaWAN is always 10 to 15 years battery life. To be honest, in reality, I think it's less because the coverage is not what it's supposed to be, because also the weather conditions are impacting a little bit the battery, and real life reasons basically. And what we see is that batteries are good. Battery life can be long because, of course, LoRaWAN is very low power compared to the others that you mentioned. But as soon as there is light, why not use it, right? There is no reason not to use light. We show all together that it's possible. We have real life examples. Now when I go to customer meetings, most of them tell me they have the Samsung remote control at home. So we are selling tens of millions of this battery-free Samsung remote control, which proves that the solar devices are a reality. It's possible. So I think it's the way to for IoT to scale.
Yeah, I would very much agree with that. And I would say to your question, yes and no. We do have customers that successfully have sensors in the field for more than 5 years, but we also have a lot of them that do not. Did we do something wrong as device manufacturers? Maybe, because of course the customer can configure the device. So very often it's kind of the customer mistreating the device, making it send very, very often, or of course bad network coverage. And when you hear 10 or 15 years of battery lifetime, then you will see a star, and then you will see something really small printed, and you will see the exact conditions. The techies among you, they will know that. You always have to read the data sheet very, very exactly. So what we did at Miromico is we started to provide spreadsheets, simple spreadsheets that customers can estimate at least in what conditions they're dealing. But of course, even that is just a simplification. So we see that a lot of customers, they had to go and replace batteries after 3 years because they didn't follow these guidelines, or they just had really bad luck and bad conditions with maybe public coverages.
So we as Nichicon, we have been in the field of supercapacitors for decades, but we decided to enter a new area a few years ago. We have been in mass production since 2019 with this. And this is an energy storage, which is a battery, but it's positioned between lithium-ion batteries and supercapacitors. And that means we don't have so much capacitance. So you can't put our battery out in the field for so many years without charging it. So that's why for us, this energy harvesting is so important. Of course, you can also manually charge the battery very fast with our technology, but you need a charge pattern, either by energy harvesting or by ultra-fast charging, like charging the battery full in 3 minutes. So as long as you have a concept for that, our batteries are good for being out there in the field in a normal ambient temperature without any doubt for 15 years.
Thanks. Yeah, we'll get back to you because the low power wide area device, that was not your thing, right? No, but I'm just wondering because my first narrowband IT customers, they did their rollouts back in August 2018. And from some of them, I know that their water meters in the Netherlands are still working on the same batteries, sending uplinks like every 10 minutes. And that's actually already impressive, right? 8 years. 8 years. And some people said that narrowband IT will never go beyond 5 years. So would you say that by using solar or any other energy harvesting technologies, we can do even better? Yeah, who wants to go first? Is this something for you?
You can go.
Yeah, I would say with adding solar and this extra power that you have available all the time, you can add functionality to your device for sure. I mean, you cover what you need, and then if you have anything extra, please do whatever you need on that.
So I could add one thing. So we try to go a little bit of a different way. So you mentioned earlier battery-free solutions, but we want to go battery-less. So we do batteries, but we want that the consumer or the user of the application shouldn't feel there is a battery. So you mount this one time, you never touch it, it lives as long as the equipment does. So this is our way to this.
Yeah, I do believe that energy harvesting adds a great value. What we've seen in the past today, I want to share some real experiences. What we've seen in the past is that energy harvesting really does add value. We can prolong the battery lifetime, or we can even be completely autonomous. But it's a completely different mindset, and it needs a lot of education to the customer. One funny example, I just talked to one of our customers deploying our battery-free sensor. And he told me, well, some sensors stopped working. Well, they run on indoor light. They had it in schools, and the students started to put their jackets on top of the sensors. And we learned from that in some cases it makes sense to have a multi-energy source approach, maybe battery-less if you know the conditions are given, but in some conditions it's also really interesting to have a hybrid energy source system, for example, with a backup battery.
Yes, for sure. And to your question about can we use lights to extend the battery life? Yes, for sure. That I'm 100% sure. I'm not 100% sure to make the device fully autonomous, but to extend the battery life as soon as there is light, 100% sure. So why not do it? And yes, I agree, of course, to somehow our customers ask us to make it invisible. So they just want it to work, right? And yeah, of course, having we are promoting rechargeable batteries and really using light to recharge them, right? It's removing disposable batteries, not rechargeable batteries.
Thanks. I'm going to stick with you, Pierre, because we've mentioned light a couple of times, but are there any more ways of doing energy harvesting these days?
Yes, you're right, and I get this question many times per day, including this morning on the booth. So yes, we are handling any kind of energy, ambient energy, and there are other alternatives than light. But light is like 90% of our projects. So the rest is heat. So in special cases, you can use what we call thermoelectric generators, meaning if you have a temperature difference of 20, 30 degrees that is stable, and you have enough space to be in contact with the cold side and the hot side, then yes, you can have for instance, in industrial environments or for a thermostatic head, yes, you can use heat to harvest energy. Then there is radio also. I get the question about radio all the time. And there's some kind of myth about harvesting the Wi-Fi in the room. Okay, that doesn't work. Let me be very blunt about that. Radio harvesting is a kind of wireless charging. So you need a dedicated transmitter. If you have a dedicated transmitter and it's a kind of wireless charging, then yes, we have harvesters, we have matching networks, we have the right power management IC for that. Then the pressure of a button as well. We can do also battery-less and like buttons. And we have a dev kit with Scilabs on the booth exactly with this. And then what else? Vibration as well, but same thing. Vibration, you need to know the frequency. It needs to be stable. So it's very rare cases for which you can harvest that. I hope I answered completely your question.
Anyone else wants to add something to
that? Maybe from our perspective, we also had a very successful project that is also scaling up now with THEs, harvesting heat. That was in the range of hot water, so we had a very nice temperature difference between ambient and hot water, really enough to run the whole system autonomously. So these projects also exist in reality, and they are also being deployed successfully.
And in the, I've got the last minutes of your previous presentation, and you were also talking about photovoltaic cells, right? And what is basically what is important to select as as criteria when you're using that? Can I start with you?
Yeah, sure. For sure, the first thing you should look at is the power conversion factor, or what power you can expect out of the solar cell. The better, the higher the better. It means you can do a smaller real estate for your PV. So that's the first thing that everybody looks at. And this is also something that I encourage you to, when you select a PV, please do the measurements yourself and compare things under the same conditions. That's really important. I would also say that it's important to know what's inside the PV. If you put something there that is worse than the battery, it's no good. And if it dies quicker than the battery, it's no good. And I would also say that for your product to launch at scale, you need to select a PV that is actually in manufacturing right now or in a very close future. Don't select something that comes from the lab. It will just bite you in the end. So yeah, that's my 3 most important things for the selection of PV.
Thanks. I think that
you wanted to add. I think your point was good in the preparation about integration. I can say.
Yeah, so we can share the answer. But I think we agree one important point is the integration into the final product. Is it designed for manufacturability, the maturity, as you mentioned? Can it scale? Not coming from the lab, and of course also really important that it matches. So we don't just have the solar cell or the storage element. You need like something nice in between, like a PMIC. You need to make sure that all of these things are matched, that you're also operating the PMIC correctly. So it's, for me, it's not just a choice of a solar cell or a photovoltaic. It's the choosing a system, and that includes at least 3 components.
Yes, you're right. And when you change one, you need to look at the others. So all the 3 go together, and their link is. It doesn't make sense to have a very big PV cell and storage element and nothing in the middle, because it simply doesn't make sense.
Also, it's important to consider where are you going to deploy your device. I mean, there are PVs that work indoor, there are PVs that work outdoor, there are seldom a hybrid that works okay. So make sure that you select one for your application. I mean, that's pretty obvious.
I just wonder, because for me, all these things that you just mentioned, I hear these things for the first time, and so it's quite new, I guess, right? And I just wonder what's holding most of these solution developers back from implementing these solutions, and starting with you, Klas.
That's a very good question that we keep, asking ourselves for a few years now. So, well, what I want to say to it is that, I mean, we are looking forward to an IoT market that should be of massive scale. And I think there is absolutely no way around this than to get this energy autonomous. So if we talk about trillions of sensors out there, it's not a matter of sustainability any longer, why you need to go this way. But it's just not going to be possible to manage this if anyone need to cable this, or if anyone need to ever replace the battery. So you had an example of maybe 8 years in a good case, but in some cases it might be 3 or 4 years. And this is just not going to be good enough. So you need to put it out there one time, and as long as the unit is somewhat up to date and possible to use from hardware, it needs to work without touching it. So I think that's our take on this, that we need to find the way together. So.
Yeah, no, it's. I think maybe you're the good example, because you say you discover this topic, and EPZ is already 10 years old. So it shows that we still have to evangelize and explain, and all of us have to do that. And you will help us now that you discovered. Yeah, I mean, of course, it's not simply putting a battery. You have these 3 components that you have to choose. You have to choose them wisely. But it works. I mean, again, we are selling tens of millions of remote controls, so it works. It's not like a new technology that just appeared. It's mature. It works, and we still have some training and evangelization to do for everybody to understand. It's not so complex, but it's possible.
Yeah, in fact, the first time that I heard about it was I think it was also 8 or 9 years ago, and I think Ines, you are working for that company, Naui Energy, and a couple of years ago, Dragula Technologies, and this is all new to me. But yesterday I spoke to 2 solution providers in smart building and agriculture, and they told me that they are already using these technologies for more than 2 years, and you're developing these solutions as well. So yeah, I'm amazed, and I'm going to help you with spreading the word. No worries. And I hope that you are also inspired to apply these technologies in your solutions from now on. We only have 5 minutes left, and I have one question to all of you. When it comes to developing IoT solutions and increasing battery lifetime, what is the most overlooked thing in IoT device development that you see today and that you want to make developers aware about? And it doesn't have to be anything with energy harvesting. If that's the case, then yes, but it can also be something else. So I start with you, Niklas.
Yeah. Right, in general, is to think low power from the beginning, I would say. We have had some customers coming to us saying, hey, can you retrofit this design with, in this case, energy harvesting, of course. And we say, yes, what is your power draw? Yeah, it's really low, it's like 100 milliamps. And we say, no, that's not low. So we need to open the mind to get that low power is ultra low power. I mean, we are talking microwatts, microamperes. So really highlight that to the designers and make sure the designers think this way from the beginning. Retrofitting a design is really hard.
Thanks.
Yeah, I can add from our side. So what normally we need to explain to many customers is that they need to rethink the way they look at an energy storage. So they may be used to normal lithium-ion battery technologies, thinking that they need a certain capacitance level. But with our different technology, you don't need close to that capacitance if you continue to refill it with, the source of the PV cell and the power management. That opens up completely new ways of designing products where you can deliver very high power with very small batteries.
So from our perspective as device makers, I would emphasize on edge case testing, not just in the case of energy harvesting. Of course, energy harvesting adds to the complexity. Suddenly we have cases like where we have to look that we don't have boot loops and so on. But it's really also the edge case testing for any possible scenario, because maybe you have some modes that could trigger leakages, could trigger higher power consumption. And we really know that because we've been on the market for more than 20 years. We did LoRa before there was even LoRa 1, and we've seen all the stacks, and maybe there are some edge cases that you overlook, and I would give you, or the ones of you who are building solutions, building devices, really the tip that you test and you torture the device until you really feel like you cannot torture it anymore, and if it's still resilient, then you know that you did your job.
Yeah, I agree with all of this. Of course, I think thinking low power from the beginning is key because some people come to us and say, "Oh, I want to do a solar device," but if they start from a device that consumes too much, it's what you were saying, Niklas. It doesn't make sense. So thinking low power is really important. Reducing the power consumption even before thinking about energy harvesting is key. And also there are already a lot of devices existing. So this is maybe a more general comment. But sometimes you have a use case, you want to build a solution. You don't need to rebuild a new device. There are a lot of existing devices for many use cases. Sometimes just buying what is already there and integrating it is enough, right? So.
Thanks. Yeah. I just wonder, because I heard it 2 or 3 times, think low power from the beginning. That made me curious, because what does it mean actually? That probably means that you saw some companies making some huge mistakes, right? So anyone who can elaborate? Yeah.
I mean, usually adding LEDs to your design is not a good way. Adding what's called pull-down resistors, if you can avoid it, don't do it. Kind of everything that consumes in idle state, you should remove as much as you can.
Okay, yeah, that explains a lot, yeah. So it's 15:02, so that's it. Thanks a lot for educating us on energy harvesting and low power design. And I hope you guys are inspired to apply these solutions in your solutions from now on. And if you have any questions, I think you are also walking around and having your booths here today and tomorrow, right? Thanks a lot.